So we are going, we wrote this down yesterday, right? So we're going to do example 11. It says, find the interval of convergence for this sequence. We are going to do that by using a ratio test, which I think we started that yesterday. Did we? Yeah. Okay, so we will start over because we were going really fast. You should have been able to do all of your homework last night. This piece will be something that we'll do different homework on, which is the endpoints on an interval of convergence. And we'll talk about that today. So I'm going to do n plus 1, x to the n plus 1, over 4 to the n plus 1, times n plus 1 squared plus 1. Okay, does that cover the whole n plus 1 set? Times 4 to the n times n squared plus 1 over nx to the n. Does that look good? Okay. What can I cancel?
You can cancel the x.
Okay, x to the n and x to the n plus 1, and what would be left? Just x on the top. Any questions so far? The 4 to the n plus 1 and the 4 to the n cancel just to leave a 4 on the bottom. Which leaves me with the limit as n approaches infinity of n plus 1 times x times n squared plus 1 over 4 times n plus 1 squared plus 1 times n. So far, so good?
So we get the limit all
Yes. So now, as x approaches infinity, we could multiply all of this out, but would you agree the leading term is x times n cubed? And the leading term down here is 4 times n cubed? And as n approaches infinity, I just get x over 4. X over 4 has to be less than 1 for it to converge by the ratio test, right? What I don't know is if x over 4 equals 1, whether it converges or diverges, and that's going to be the new thing for this problem. But let's go ahead and do the interval of convergence. The first part would be negative 4 to 4. Everyone agree? What I don't know is what about 4 and negative 4? Because remember, the ratio test is invalid when the limit equals 1, and I must use some other test. Any questions so far? So the first thing I'm going to do is plug in 4 and negative 4 and look and see what the sequences look like. So let's start, was it n equals 1? Was that what it was? N equals 4 to infinity of n times 4 to the nth power over what was it? 4 to the n squared plus 1. If there truly is a 4 to the n on top and bottom, would you agree that this is n equals 4 to infinity of n over n squared plus 1? So I want to know, does this converge or diverge, and how do you know?
Convergence.
That's not a rule I know of.
Is it like it's because it's less than one converges? Or is it converges?
I don't know if it converges or not yet. I need to use some type of test of some sort, don't I?
Limit comparison of 1 over n.
Good. Limit comparison with 1 over n sounds perfect. Why 1 over n?
Because you should see the
Yeah, this, as n goes to infinity, behaves a lot like 1 over n. Everyone agree? And so if we limit compare with 1 over n, which we did a lot of those, flip and multiply. As n approaches infinity, you agree this limit is 1? Which is a number. Remember, that one can be 1. It just has to be a number. If that's a number, then they behave the same. And what does 1 over n do? So I know that these two sequences behave the same. This behaves the same as 1 over n from the limit comparison test. My question is 1 over n, what does it do? Right, and that diverges, right? Right. Now, you don't actually have to say that you can just know that it diverges, but that means this diverges by comparison. Right, this one diverges by p-series. This one diverges by limit comparison. Therefore, at 4, the sequence diverges. So I've checked one of the endpoints. At 4, it does not converge. So now what do I need to do? Check -4. There is hope for -4 because of what test? Well, let's just plug it in and find out. What did we have? N -4 to the n. Mm-hmm. With which one?
This one right here.
Oh, I don't know yet. We'll see. Let's see, simplify it. -4 to the n divided by 4 to the n. Those don't quite cancel, but they almost do, don't they? What do they leave you with? They leave you with -1 to the n. What type of series has a -1 to the n? What does that cause? It causes an alternating series. Do you agree? So this series alternates. Is each term positive other than the -1 there? So it fits it does alternate. Do the terms decrease in value? Oh, sorry, there's not a 4 to the n on the bottom. What happened to the 4 to the n? It canceled, sorry. As these terms increase, doesn't this look like 1 over n? We already decided that this looks like 1 over n, right? Does 1 over n go to 0? The terms decrease and the limit equals 0. So is this an alternating series where the terms decrease? Let's go back up to the alternating series test. If those three things are hit, then this series converges. So essentially, an alternating series test takes a series like 1 over n that does decrease in value. The limit is 0, but it normally doesn't converge. And it makes it to where it does converge because why would an alternating series converge when a non-alternating didn't?
It's sort of canceling.
Yeah, it's sort of every other term is subtraction. So unlike a series that doesn't alternate, you have some canceling happening. So that's why an alternating series could converge even though the non-alternating series does not. So this converges. So my interval of convergence is -4 to 4, including the -4. Now, you didn't have to do this on last night's homework, so if you didn't, don't go back and do it. You don't have to yet.
How do you know what you need to do?
Anytime you are doing an interval, you will need to check the endpoints. But at that point in the book, they hadn't taught it yet, so they weren't looking for you to check endpoints yet. So now we'll start checking those. We'll start checking endpoints. Anytime you use a ratio test is how you know, because the ratio test fails at when the limit is 1. I do want to introduce you to another word that is not tested on the BC exam, but does come up in your textbook, so you'll know what it means. There are sequences that converge, and then there are sequences that converge absolutely. Absolute convergence means it converges whether it alternates or not. So 1 over n converges only if it's alternating, if the -1 to the n is there, but if not, it doesn't converge, and so that's called conditional convergence. It only converges if it alternates. So just if you ever see absolute versus absolute convergence versus conditional convergence, that's what it means. That is not a BC tested topic, so you don't technically need to know it, but if you ever see it in Cal 2, if you ever take Cal 2, you will know. Okay, let's look at this one. So now we have every option available to us. However, what seemed to be the easiest when we had an x involved to find an interval? What was our kind of our go-to that we're going to use a lot? The ratio test. I'm going to use the ratio test to get that interval of convergence. Good question. It is an n+1, yes. So I am going to use a ratio test. So anytime I'm looking for intervals of convergence, it's a good idea, unless it just happens to be geometric and you can see that it's geometric, and then you could do r between -1 and 1. Oops. N approaches infinity. -1 to the n plus 2. Are y'all okay with me writing n plus 2, n plus 1 plus 1? X to the 2 times n plus 1 over 2 times n plus 1. And are y'all okay if I go ahead and flip and multiply instead of writing a division and then doing it? 2n over, and the -1 can go either place since it's just -1, but what are some things that cancel? By the way, you might want to write this as 2n plus 2. The x to the 2n plus 1, that's in parentheses, so you get 2n plus 2. Now what cancels? The 2. Oh, the x to the 2n. Everyone agree? But you would be left with x squared on top. Let's use green. X squared on top here. That one's just gone. Good. -1, and I'm going to say on top, but, top, bottom, -1, it doesn't really matter. So I get the limit as n approaches infinity of -2n. Everyone okay with how I got that? Oh, and x squared. The what? This one? Oh yeah, I might have not done that. Good, let's cancel it. I like that idea. So -n times x squared over n plus 1 As n approaches infinity, I get negative x squared. Everyone agree with that? Yes, no, maybe? So I get, and I want that to be less than 1 in absolute value, which means it needs to be between negative 1 and 1, not in absolute value. When I divide by a negative, what happens? Okay, it switches the signs around. You might would have just known that, but if not, there it is. So x should be between negative 1 and 1. Square root all three parts. I'm going to turn it back around, but you don't have to. You could leave it. X stays between negative 1 and 1. Oh, good question. Yeah, technically, you're right. Let's explain that a little more. I'm not really just square rooting all three pieces, because then you get an I. That doesn't make sense. But one, I want to think about it, and then two, I want to explain it algebraically. Thinking about it, if x squared stays between negative 1 and 1, would you agree that x would just have to be between negative 1 and 1? As long as x is between negative 1 and 1, though, square it stays between negative 1 and 1. So logically, we could think it through. Technically, what you'd have to do is kind of double the thought on that. X squared is never going to be negative, but it's okay that x is, because when you square it, so you have a couple of ways to get there. We're not just square rooting, but anytime you have a square between negative 1 and 1, the square root would have to still be between them. If it were between something like negative 2 and 2, then the x would be between negative radical 2 and radical 2. So you can kind of think about square rooting, but you don't actually get imaginary numbers there. Okay, I do need to check the endpoints, and I'm going to do that by writing two sequences with those endpoints plugged in. Negative 1 to the n plus 1, and you have 2 that you can write 1 to the 2n, n equals 1 to infinity. So I'm going to check endpoints. The other one, n equals 1 to infinity. Did I write it down right? Mm-hmm. What do you know about any negative number to an even power becomes positive? Would you agree those are the exact same sequence? So I really only have to check one, because those are the exact same thing. And what is 1 or negative 1 to the 2n power? Either way. 1. So really I'm checking the sequence negative 1 to the n plus 1 over 2n. Both of those equal that. If the negative 1 weren't there, this would be a good candidate for the comparison with 1 over n, and it would diverge. However, the negative 1 is there, so what test should I use to check this? Alternating series. Is it alternating? Yes. 1 over 2n, is that decreasing? Is the limit as n approaches infinity 0? So this converges by alternating series test.
So you won't look at the things that aren't in an X. Like why aren't you looking at the n plus 1?
The negative 1 to the n plus 1? it's just causing it to go -1, +2. It's the thing that's causing it to alternate. Which technically it would it would still go to 0, but what I really want to look at is, besides -1, +1, -1, +1, does the rest of the sequence go to 0?
Do you have the announcement somewhere?
Yeah, maybe. What do you need to know?
I don't know, like 25 cents.
I think I have it pulled up on my phone because I've been checking it all day.
I think it was 25.
So, would you agree this converges at all endpoints? It is 125. Agreed? Let's do another one.
There's not 3 left.
2. And they're only examples. I'm done with material. We're just practicing. I figure you could stand to see me practice. Did you get everything back there? Did y'all get everything? Do I need to go back? You could ask. All right, find the interval of convergence. Again, what's kind of my go-to test when I'm trying to find the interval of convergence? I've got an x involved. Ratio test. Ratio test is really a good go-to test in general. If it's not one that you can easily see a comparison to, a ratio test is a good go-to. The only thing its weakness is the endpoints, because of the limit being 1, it has an issue with it can't tell. Can't answer that question. Otherwise, ratio test is going to answer most of your questions, except when you have that limit being 1. So I'm going to do the limit as n approaches infinity. I'm going to go ahead and flip and multiply if that's okay with you. So we're going to do that so many times. Good. 3's. Good. X minus 2 to the n and x minus 2 to the n plus 1 just leave you with an x minus 2 on the top. So I get the limit as n approaches infinity of n times x minus 2 over n plus 1. And as n approaches infinity...
So can you not, like, since that 3 in on the bottom left looks like 3n plus 3,
I canceled the 3's.
I don't know, like, if you went ahead and did the 3n plus 3 on the bottom left and then canceled them.
That would work, but you would still have a 3 on the top as well. And so then you would end up with 3, you would have a 3 on both of these places if you did that. What, say that again?
Like on the bottom left side out, you go ahead and factor that 3n plus 3, and then you take out that 3n.
You can't,
You take this
because the plus.
So why is the n plus 1 and the x minus 2 to the n, why is that canceled?
The x minus 2's.
you get the
So this is x minus 2 to the 5th power, and this is x minus 2 to the 6th power.
So basically it just leaves
One of them at the top.
you get n plus 1 minus 3.
Yeah, subtract exponents. But you have the same base.
So you just left
Does that make sense?
the way you
Okay. As n approaches infinity,
So it's x.
good, just x minus 2. Any questions so far?
all you have to do
They both are the exponents of the n.
Exponents.
Or not exponents, the coefficients of n. Like n is with both of them. Does that make sense? And so you will want to leave it factored out. And so what happens is this is the 1 doesn't matter because it doesn't have an n with it. Does that make sense?
So since they all have one,
I did the limit as n approaches infinity. Which, as n gets really big, remember this 1 doesn't matter. And so yes, then you get the ratio of those leading coefficients. Good so far. Add the 2 to everything. So x is between 1 and 3. Yet again, what do I need to do? Check the endpoints. Again, on last night's homework, you don't have to do that step. That textbook hasn't taught it yet, so they're not going to be testing whether the endpoints converge or not. So you can, on last night's homework, this is where you'd stop. The 1 to 3, good enough. We'll go with that for now. Part of me doesn't like the way the textbook teaches it that way, though, because then you might forget to check endpoints. So I kind of like teaching it all at once so that you always know to check endpoints. But on last night's homework, we can go with the way the textbook does it and just do the interior convergence. But we will do homework on
so will we
endpoints.
check the endpoints on all of the things that we test?
Mm-hmm.
We test on, or just on everything?
Anytime you use the ratio test.
Okay.
And let me remind you why it's when we use the ratio test. If I go back to the ratio test, if the limit is 1, we don't know if it converges or diverges. So that's why you have to test the endpoints using the ratio test, because that test fails at when that limit is 1. Any other test you're using, you won't need to, but for the ratio test.
So what do you mean by limit is 1? Is that just like...
So remember here we just did this limit, and we said, I want to know when this is less than 1, because that's when it converges. But I don't know actually if it converges or diverges if the limit equals 1.
Okay,
so when I say less than 1, I am finding when it definitely converges. There's a chance that it may converge at the end. And so that's where we're testing those endpoints. And technically, anytime you do a ratio test, if you have an x, now I also want to point out a lot of the time we don't have an x involved, and then it's just a straight test. We're done. The only time we end up with an interval at all is when there's an x involved in the sequence itself. And so it converges on certain x values, but diverges on other x values. So answer all of that. Okay. So I need to check the 1 and the 3. To do that, I'm going to plug them in. What am I plugging them in for, Joseph? No. What are they? X is between 1 and 3, right?
So it's going. The first one would be negative 1 to the unit number 3. The second one would be 1 to the unit number 3.
Does it matter what this sequence starts at when I'm doing any of these tests?
No, because you're going to infinity.
No, yeah. So it would change the sum, but it wouldn't change whether it converges or diverges. And what was it? 3 minus 1 to the n?
1 to the n number 3.
Now, when we're new at this, we're kind of fumbling through it a little, but we're getting a little better. What is 1 to the n?
It's going to be
It's just 1. 1 to any power is 1, right? So this is just 1 over 3n. What would I compare that sequence to? 1 over n, and what do I know about 1 over n? It diverges. I'm getting a little better, right? I'm getting a little quicker with that. If they don't say justify, I'm just going to stop and go diverges. If I need to justify, I can limit compare it to 1 over n and say, or actually I could Yeah, limit compared to 1 over n. And then I could say diverges because 1 over n diverges by p series. I could do all of that. The p series is the 1 over n to the p power. And if p is 1 or less, then you diverge, and if p is 1 or greater, you converge. Or if it's greater than 1. Do what?
I had that question before. Now I feel dumb.
No, it's okay. But this one,
It converges by the alternate.
it converges because it's alternating. It would diverge if it were not alternating. So this one, what we would say is it conditionally converges. It converges because it's alternating. So this converges by alternating series. If you are not doing a justification, you don't need the by alternate. You can just answer the interval. I'm showing a little more, talking a little more because you may have a justify. But at 1 it converged, and at 3 was it 1 to 3? I can't remember. And at 3 it did not converge. So essentially, we kind of converge at endpoints when we have an alternating series. That's why the ratio test fails, because it doesn't know at the endpoints whether it's alternating or not.
So basically, all the tests you can just go steps are there into tests.
There are a lot of sequences that can be tested a lot of ways. So ratio is kind of a good go-to. If you don't know what to use, you can try the ratio test. But when you get into something like this, we're going to have to do more of a comparison test. The two sequences we can compare to, the ones you'll really want to get memorized, is p-series and geometric series. Because those two are kind of our go-to comparisons. One more, and we will be done. We didn't end up with a lot of work time. And let me talk homework for a second. We are going to grade this homework that you've had forever on Monday. The one that, yes, this is the one you don't have to do the endpoints on. It asks for convergence, divergence, it asks for the radius of convergence, and it does ask for intervals, but again, they assume at that point in the textbook you don't know how to do endpoints. This homework is the one where you'll take into account endpoints. Other than that, it will look very similar to the last homework, but then you will test some endpoint comparison. We will grade it on Tuesday. And keep working on power series. There's no due date yet on those. These have due dates. Those don't have due dates. Because we still haven't learned error. We still need to learn error. Other than that, there's a lot of stuff on them you can do, but we're going to be able to find out how far off our sequence is. Like if we're accurate to 3 decimal places or 2 decimal places. Eventually. Okay, what am I going to do on this one? A ratio test. Are y'all getting better at these? I know the first day it was probably a little overwhelming. Yes. Any questions so far? Those cancel. The 3 to the n cancels with the 3 to the n plus 1 and just leaves you a 3. So I'm left with the limit as n approaches infinity. N square root of n times x. You can't get rid of them. However, though, as n approaches infinity, you can kind of go, well, these two things have the highest power of n to the 3 halves. or whatever you want to think about that as. And so x over 3 is going to be what that limit approaches. Gotta be less than 1. Negative 3 to 3. It would not be a bad idea to write the n times the square root of n as n to the 3/2 power. Does everyone know how I got n to the 3/2 power? N to the 1 plus n to the 1/2. So one of the endpoints I get 3 to the n over n to the 3/2 times 3 to the n. The other one I get negative 3 to the n. This actually converges by p series because 3/2 is greater than 1. So it definitely converges when it's alternating. So it converges at both endpoints. Have a great weekend. Remember, the only homework you have to do is the bookwork that you've been working on. So, if the exponent on the n is greater than 1, and it diverges if it's 1 or from 0 to